So my name is Helge Brattebø. I'm happy to share my thoughts and experiences on this topic with you. Actually, I don't really know in detail your background, but I know that you have a quite varied background. So I guess many of you would really know a lot about the sustainability concepts and also different challenges and aspects about the plastic cycle already. However, I tried to put together some of the thoughts and some few experiences also from, let's say, practical setting in Norway when dealing with plastic waste management. The title is Sustainability Concepts and Applicability to Plastic Waste, which is a huge topic. I will touch upon some of them, and I try to look into some of the literature as well. Well, 1.5 years ago, roughly, or maybe it's 2 years ago, I held a popular scientific lecture on the same topic. And before that, I did quite a lot of scanning through literature, and I have a couple of super interesting slides related to the plastic waste that I would like to share with you. My background is a professor of industrial ecology. I was originally a civil and environmental engineer, and then I started working with, let's say, end pollution, wastewater treatment, water treatment, solid waste management, and so on. Over the last years, I've been working more and more with systems analysis, industrial ecology approach to sustainability. And I'm also a director of NTNU Sustainability, which is kind of an overarching umbrella organization at NTNU for strategic interdisciplinary approaches to the problems we face. So what do we face? If you take a look on different sectors in society or product systems, value chains, and you would like to apply the sustainability thinking to them, you immediately today run into the global SDGs. When I was younger, which is some time ago, we talked about the Brundtland definition and the triple bottom line, meaning you had environmental, you have economic, and you have social sustainability, these three dimensions that should be balanced. And today, when you look at the sustainability today or sustainable development, you see the 17 global SDGs as a carpet with different goals in parallel. And of course, several of these will be relevant to individual, let's say, product systems or specific challenges that we face in society. And when you look at the plastic product cycle or plastic waste challenges, I would say that you would have several goals that is highly immediately understood to be important. For instance, related to value creation, which is an important part of why plastics are produced in the first place and have a important role in the value chains of products, bringing the products safely from production to consumers, for instance, and also in other kinds of applications. So these goals would definitely be goal number 8, which is good jobs and economic growth. Number 9, which is innovation and infrastructure. And number 12, which is responsible consumption. When you look at the pollution aspects of the plastic cycle and plastic waste, definitely we know that this relates to clean water. It relates to climate change, and it relates to life below water. And particularly when you're looking at the ocean waste problem, of course, you directly target the life below water problem. But not only that. And this means that in practice, dealing with the plastic cycle, plastic product cycles and plastic waste, we have to relate to several goals in parallel. However, maybe some of the goals, maybe also one goal only, is your main target. But looking at that without also taking into consideration some of the other, even if there is co-benefits or if there is conflicts, so you need to harness these co-benefits and you need to tackle the trade-offs between potential conflicts. You cannot look at only cherry picking some of these SDGs. And that's more or less the same in all sectors, and certainly also in plastic waste. So this means that you will have dilemmas that you need to relate to between different goals. How do we understand these dilemmas? I guess that is very much about the problem in practice and in practical policy setting today. You've also seen maybe the diagram to the right-hand side here, which is kind of the wedding cake version of the SDGs presentation developed by, by the Stockholm Resilience Center. And that pinpoints a little bit better that the different SDGs are related. There are interdependencies, and they are also how they are more directly linked to what you could call the basic natural capacity, nature's capacity to regenerate and so on. So you have goals number 6, number 13, number 14, and 15 that all constitute the foundation relating to biosphere. And then societal goals should actually be based upon or within the frames of the biological, let's say, constraints and the biological goals, which are more long-term, more fundamental. And on top, economic goals would have to be phrased within the societal, let's say, challenges and societal conditions, and therefore societal goals. So strictly speaking, in a more interrelated approach to sustainability, of course, we are also not just cherry picking some of these, but we are looking at the interdependencies, but still we are focusing on, in a long-term setting, more the biosphere related goals. And the same actually would go for plastics. I'm a professor of industrial ecology. Maybe you have not heard about industrial ecology, but you certainly heard about ecology. Industrial ecology is fairly much the same, but we don't study necessarily natural systems. We study production-consumption systems. So the industrial society, or post-industrial society as well, meaning we are looking for the understanding the metabolism in production-consumption systems and the environmental impacts of that metabolism. So what is a metabolism? Your metabolism and my metabolism as a body is the conversion of substance and energy, right? To live. And that's the same in a society, in a sector, or for a product, let's say, group of product system. It has its value chain. And so there is a metabolism, there is flows and conversions of energy and matter transformed through products in order to meet the demands with people. So that's the function. And then you have the byproducts. And this means that you can follow the value chains from the raw materials through production facilities to the consumer in the post-consumer phase with secondary consumption, if you have that, and secondary production, over to the waste management side on the left in the figure, and then hopefully with more and more recycling, recovery, so that you can have the cyclic nature that you very often find in the natural ecosystems. So we use different methods in order to examine what we call the physical metabolism. We use that in order to examine and to understand, for instance, what is the global resource efficiency of this system? To what extent does the resources that we extract produce a value generation, benefits to and avoid environmental impacts to the society, to the users, to the companies involved, to consumers, citizens, and therefore to society. For instance, what is the resource efficiency and what are the environmental impacts of the product cycles related to plastic products? So we do that for quite a few different, let's say, application areas like electric vehicles, power systems, branches of waste treatment, shipping, buildings, and so on. And we more or less always use the same methodology. It's material flow analysis, studying materials, it's life cycle assessment, studying the product systems, and looking for what are the environmental impacts over the life cycle. Footprint analysis and input-output analysis, which is basically econometrics that we add environmental information to in order to come to the footprint analysis. So when we do that, in order to look at different systems, what is the aim of that? Well, this is one branch of sustainability analysis or assessment. where we are not directly looking to the social and the economic aspects. However, we're looking to a broad group of environmental impacts. So let's be honest, this is not sustainability assessment, it is environmental sustainability assessment. So we have to add to that toolbox also methods relating to economic development and social welfare. However, when we do this, for instance, for plastic systems, what does that tell us? How do we do it, and what does it tell us? So let's take a closer look into some of the plastics. This is a photo. It says "Knowledge for a Better World" in Norwegian. That is, by the way, the vision of NTNU. And in the background, you see the main building of NTNU. And here are two master students in a self-built car at university. Super lightweight car with super, let's say, little consumption of fuel. Obviously made of some plastic polymer fiber composite type material. So what are the problems related to this? During one day of some hand picking on the shores of a small island outside city of Trondheim in Norway, this is what some people found and brought home: plastic marine ocean pollution, right? If you look at the plastic waste management in Norway, I guess Norway is fairly similar to other Nordic European countries. I don't actually what would be the situation on this area for plastic waste management in your country or countries. However, sorry, the slide is in Norwegian, but altogether this is the total numbers of plastic packaging waste. So there is roughly 120,000 tons of plastic packaging in a country of some 5 million people. 44.4% of that is materials recycled. 52.7% is energy recovered. And that means if you sum these, you come up to 97.1%, which is recovered in one way or the other. So to what extent is that a problem? If we link this to the emerging, not emerging, but to what we see every day, the huge problems with plastics in the oceans and related to cities. Of course, situations are much, much worse in many other countries. But still, if you look at it from a sustainability point of view, with respect to a matured and economic well-off country like Norway, is this a good enough situation? We know that in Europe, you now have the circular economy policy package and regulations, directives, and so on, telling that we should have 65% of the municipal solid waste for packaging products actually materials recycled. So, which is much larger than what we see in Norway. And if you go out in the field and examine what about the household waste that you have in Norwegian cities, to what extent, where does it go, and to what extent is that a problem? So this was actually released. This is just a news release from the Norwegian main news on the Norwegian broadcasting in one day in October 2018, where there was demonstrated, there is a reporters now in northern Norway, in a smaller city or town, and a district around there. They had to dig down 4,000 cubic meters of plastics. That's 70 to 100 trucks of plastics just during that summer. That plastic was, and in the system and in a country where you should have a fairly mature system for managing plastic waste, meaning it's not going to be dug down. It's either going to materials recycling or energy recovery. So this is the plastic no one wants, right? We are drowning in these plastics. And if that happens in Norway, what about India? What about China? What about the developing countries and so on? So obviously, plastics is not a very easy system. We have the waste hierarchy and the circular economy principles. And when we have that, and these are supporting the policy and economic instruments, investments, subsidies, and so on, from government to the different actors in industry. Why is it so difficult to achieve the waste hierarchy and the circular economy for plastic products and plastic waste when we, in many countries, have just insufficient disposal? There is not recycling, reduction, or prevention. And also, we are not able to implement the circular economy in a good way in Norway. And we are far below, actually, the circular economy, let's say, policy targets that are set and to be met in a very few years. Why? Well, I thought of that, and I concluded, let's focus on some basic questions. What are these basic questions I would focus on? And looking to in my own kitchen and in my own, let's say, household garbage, we are sorting package in Trondheim in special bins, and so trying to source separate plastics from other waste. What about plastic waste quantities versus economic growth in my country and in other countries? There is economic growth through the different decades, right? Quite significant economic growth, and that leads to also growing consumption of different kinds of products. And with all these products, of course, comes packaging. There are lots of other plastic products that will also grow in quantity if there is economic growth in the construction sector, in the agriculture sector, and so on. So it seems kind of inevitable to avoid the growth of plastic waste generation if in situations where over time there is continued economic growth. So therefore, that points to the top on the left side, the prevention, let's say, policy or priority. It's difficult because there are not in reality very good substitutes for plastic packaging. They are there. The plastic packaging is there to protect the goods from the factories and through all the production chain to the end user, for instance, in food. Second question, all plastic products from renewable sources like bioplastics, would that be an option? Of course, that would be super nice, because if it's bioplastics, it means that the production of those plastics would really pollute less during the different stages of production. And the other alternative, of course, when you have waste, because you will have waste, what if all the plastic waste was biodegradable or recyclable? Today, is it biodegradable? No, definitely not, because we see the plastics accumulating in nature. Is it recyclable? Well, that is mainly why we see things like this. Large shares of the plastic waste is not recyclable. So how to relate to that? Because fundamentally, in the sustainability overarching concept, we would say, okay, we need some plastics because the plastic has a function in the system, in the production consumption system that we relate to, for instance, for food. The production of those products should be environmentally friendly. The waste should be biodegradable or recyclable. And of course, much of the challenge relate to this picture here. The challenge of recycling of plastics is very, very tightly related to the chemical composition of the different plastic polymers, the nature of those polymers. Here you see from the left to the right, PET, HDPE, PVC, LDPE, PP, PS, and other. So these are different plastic polymer types, right? And you see what they're used for. For instance, PET, beverage bottles, food jars, clothing, carpet fibers, some shampoo and mouthwash bottles, and so on. And then there are some numbers on the bottom. There is 11%, 40%. So this is the percentage of the global plastic waste as estimated in 2015. And you see that there are large percentages on these products to the right in red. There is 24% of other. So there are lots of other products, mixed products with additional, let's say, substances in them, with a more complex chemistry. There are 20% of low-density polyethylene, 90% of polypropylene, and 6% of polystyrene. So, okay, that's fine. We understand that. But if you look also on the on this side, sorry, I should have put in blue there. I just told you that. But if you look on, whoops, that was not the meaning. On the red bar there, you see to what extent the different polymer types are easy or difficult or very difficult to recycle. And that's actually much of the problem here. Very many of the types of polymer that were used in super many different types of products are not easily recyclable. Okay, so then it means if they're not recyclable easily, either we have to change that composition of the plastics, substitute those products with other kinds of products, or we need to burn them in order to get at least the energy out of it. So we did a study. By the way, I had a tick on my screen here. That's an email message, but that reminded me that if you post questions in the chat or raise your hand, my setting is so that I cannot see it. So we will have to take questions afterwards. We did an example study for Trondheim. This is a master study a couple of years ago, doing material flow analysis and life cycle assessment for plastic waste management in the city I live in. Trondheim is roughly 200,000 inhabitants. And we looked at the present situation and scenarios future. What will happen if Trondheim is about to introduce a new central sorting facility for food waste and different kinds of packaging waste. And then what happened if gradually phasing in bioplastics. I will not touch upon the bioplastics here, but I will touch upon the scenarios and the present situation. So what we do as an industrial ecologist, and what Ermelin did, she made a box diagram. This is a flow sheet of the different processes in the packaging system in Trondheim. Or related to Trondheim. So actually you go from the left, I don't know if you can see my cursor, but you go for, that's the generation of plastics and bioplastics, and they are used in households in Trondheim, and then the waste is generated in the households. It's collected, part of it is incinerated, the part which is obviously just sorted as residual waste. Part of it is sorted at the source, meaning that it's collected separately, then it's transported to packaging in Hextamon. Some of it doesn't hold sufficient quality to be sent for further downstream sorting, which happens in Germany. There are 5 large facilities, industrial facilities in Germany. Norway does not have an equal, let's say, facility domestically. And the waste that is not holding the sufficient quality to be sent for sorting and recycling downstream, that is just sent to incineration in Trondheim. So there are 2 flows to incineration. When the waste comes to Germany, the objective, of course, is to have as much as possible recycled in Germany, and thereby substituting virgin materials, going to other products, right? That's the purpose of recycling. Not all of the plastics has that quality, and therefore some of it is used, quite a large share actually, as an energy source in cement production for the temperature need in cement production in Germany. Some is also just incinerated in Germany, also because it doesn't really hold the quality demand. And some of it is not, at that time, was not treated in Germany, but was exported all the way to facilities in Asia in order to be recycled in Asia. However, to a large extent, that is the worst quality packaging plastic waste, because the best one is handled in Germany. And I would assume, and people assume actually, that very much of that plastic was not recycled in Asia. It ended just disposed of, and partly in uncontrolled landfill And that was also proven because only a couple of months after I made this, or my student made this work together with me, Germany decided not to send their waste to Asia, actually because the Asian country, I don't exactly remember which it was, it didn't approve any longer to accept the waste because it's caused problems. So you see the system is complex and the aim of course would be in a mature, well-off country like Norway with lots of knowledge and I would assume economic muscles, what is the resource efficiency and the pollution problems of this system? Well, if you look at the two blue dots on the right-hand side, that would be my understanding of the quantities or identifying the flows actually with an output, strictly speaking, where there is recycling. All the other outputs does not involve recycling. And the red dot on the left side, that is the generation of household waste. So if I just sum the quantities on the blue side and divide by the quantities on the red side, I have the recycling rate. And in 2017, the numbers tell us that the recycling rate was 13%. And Norway reports, right? Remember 44.4% materials recycling. And Trondheim is not that a non-typical city in Norway. It is one of the better cities. So that means that the public reporting does not necessarily reflect what is actually recycled, because when you are sorting something in order to be sent for recycling in another country, you are reporting that as being recycled. However, clearly here we see it is not. This situation could be improved a lot if Trondheim is implementing a central sorting facility, because that hits actually some of the problem on the early stage of this system, early phases of this system. So a central sorting facility with what we call realistic sorting efficiencies would increase the system efficiency from 13 to 29% roughly. And if there was ideal central sorting, which may be quite difficult to achieve, it would increase it to 67%. So we see that there are two main messages from this picture. One is that in a system like ours, if you apply sustainability concepts to it and try to fill that with the political targets and economic systems around it, like producer responsibility and so on, and compliance with the national, let's say, goals and laws, still you have problems. You have problems reaching high systems efficiencies. So globally in this system, there is, of course, huge environmental problems related to the leaking flows and uncontrolled disposal. And there are huge problems related to low resource efficiency. So this is just a picture of a central sorting facility just outside Oslo, city of Oslo, the capital of Norway, in a smaller town called Lillestrøm. And this is high technology, high-tech solutions for managing the sorting of different, let's say, chemical fractions of plastics. I will not go into the details on that. I will just now continue with the bioplastics. What is it? Of course, there are different types here. The two main types are these are biodegradable and recyclable. If biodegradable, that's related to a standard. If they are recyclable, they are in practice more similar to plastics from oil. But there are advantages and disadvantages here. And the question I examine is, to what extent is plastics really biodegradable? And you can examine the slides later. I don't take the time to go into the details. But the main problem here is that the formal requirement of getting an industrial certification that these plastic polymers is biodegradable, that is based on the fact that you are meeting certain, let's say, test experiments in this international standard, EN 13432. and that relates to thermophilic composting under very controlled conditions. But this is really uncertainty in practice. Due to natural environments have different conditions, there is large variation in polymer chemistry, and there is not many studies done actually on the real life degradability with solid scientific documentation. The curves here, the graphs tell us basically that during a number of days, up to 120 days, what is the fraction in percentage, the accumulation of initial carbon lost? So to what extent is the carbon that you find in, let's say, different products like cellulose paper or plastic of different types and so on, degrade? If you are high on the graph, there is a good degradability. When looking here at some of these plastics, and there are in the tests a reasonable degradability, but if you incubate it in soil, you see you have very many of these curves on the lower percentage degradability level. 10, 20%, 40, 50%, definitely not 90, 100%. And if you do it by fermentation, I mean, in order to anaerobic conditions, also very much of the plastics will still be there. There is a very low degradability. So these results point to the fact that even if you have industrial certification on biodegradable plastics, these plastics in nature would really not be degradable. What about the future plastic cycle? This is also a very interesting article, Zhang et al. From Stanford, publishing Chemical Reviews in 2018. You see the reference on the lower side there. It takes the whole, let's say, life cycle, the value chain of different, let's say, of plastic polymers, from the resource to feedstock, to the monomer, to the polymer production, and then for the use, right? And then you have the product with its waste. So either you would have to increase to improve the qualities of the polymers on the production side, or you would have to do something on the waste management side. And this is what is called innovation leverage points. So where do we find, let's say, important, promising innovation leverage points? Is it only mainly one place we are looking at? No. This review article says, research tells us that there are really important and challenging, but also interesting, promising innovation leverage points all around the picture, all around. On the production side, for platform chemicals, polymers and recyclable bioplastics, and on the waste management side, so that you can have a conversion back to monomer or feedstock. This is promising, but also it tells us that it takes time to develop these, let's say, mature, economic, favorable, and robust solutions. So therefore, we are looking at the question, which polymer types in the future will be good polymers? And that's a lot of energy related to that into research. I will also not look into this, but please go to that literature. It's that publication. It's super interesting. And it tells us, if you are in the red area, this is a fossil source, avoid it. If you are in the yellow area, with the yellow circle, these are polymers that are highly renewable, but not degradable. So if they're not degradable, okay, then you rely very much of being in a country with a very sophisticated and well-developed recycling system. And in the green, sorry, it says green, but it should be orange. Upper right, it's also renewable and degradable. So those are the polymers that we should be looking for in order to have a widespread use. So you could sum up the plastic challenge from a research perspective, like what Zhang and colleagues did. One of the formidable challenges for the development of sustainable polymers is the economic power and the success of today's plastics industry. I mean, these are big players. Bluntly stating, it's a formidable challenge just to challenge them. Secondly, there is a need for continuous assessment of whether a new type of plastic is more sustainable than the existing ones with verifiable methods. And this is also a challenge. It's not so easy. Thirdly, the closed cycle materials will require scientific and economic innovations at all stages, all innovation leverage points of the plastic life cycle. And lastly, the development of new alternatives is a crucial and big challenge for a future sustainable industry. So what does that tell us, right? It tells me that this is just not a very straightforward, simple problem to solve. We need to relate to the fundamental questions of the interest of those industries. We need to understand the cycles, and it's not enough just to target one player. Many players, many actors along the cycle, the life cycle and the value chains of plastics needs to be involved. There are promising technologies and solutions there, but we just have to accept that it takes time to develop these. And in the meanwhile, we're trying to do the best what we can. And certainly what we should do is do everything we can in order to avoid shipping, exporting, and disposal of waste in uncontrolled conditions. Burn it if you have to for energy. However, try to recycle more and more as you can. Thanks a lot. So that was my last slide. I will stop sharing, and then we have some minutes for questions. Please.
Thank you so much, Helge. I don't see any questions in the chat yet, but thank you. That was a very thorough presentation, and I especially liked your flow diagram of the waste. Can I ask, do you have an opinion on, I know there have been some updates to the Basel Convention and the shipping of waste and things like that. Do you have any opinions on that and how it relates to your talk?
It has influenced at least the Norwegian opinion and the public opinion in Norway, and also challenging and then influencing the political decisions and what we do, right? So therefore, that goes in the direction. There is now a trend in Norway for the larger cities to really go for investing quite a large money in new solutions for plastic waste. To what extent it has influenced what is done downstream? I mean, since Norway does not have any advanced plastics waste treatment facilities, we rely on exporting that. So to what extent that has influenced and made changes to the practice, and for instance, in investments in other solutions in countries like Germany, I don't know.
Thanks, Helge. There's a question in the chat that says, hi, Helge, yeah. Do you think plastics that would actually readily degrade in the natural environment should still be high quality enough to be suitable for recycling?
Yeah, this is one of the challenges I didn't mention. Sorry, I should have. Thank you, Martha, for asking. Because what we hear also is that bioplastics is kind of, which is more degradable, is kind of polluting, destroying, contaminating the product quality of recyclable plastics. So it means if you have a system with the source separation and with the recycling of larger quantities of more fossil-based plastics, and you mix that with growing quantities of degradable bioplastics, it will be more difficult to have the mixed stream becoming successfully recycled in the end. So that is really a practical challenge today. What does it tell us then? Do we have to develop two separate collection systems, one for degradable plastics and bioplastics and one for fossil conventional plastics? We don't know yet. Do you believe that cradle-to-cradle approach is realistic within the waste value chain? It's not realistic, 100%. Cradle-to-cradle meaning full recycling. It's certainly not realistic due to the complexity of the chemistry and due to the economics. And even if you have let's say a much more well-defined and controllable plastic flow to relate to, the more you increase the recyclability towards 80, 90, 95, 98%, so full cradle to cradle, the cost is increasing exponentially. So there is a cost benefit, let's say, crossing point at somewhere. How much are compostable plastic taking up in the Norwegian system? So, well, compostable plastics, what is compostable? Because you can, yeah, if you say biodegradable with the thermophilic degradation, to a very little extent. I don't actually know the numbers, but there is not yet much of a percentage share of bioplastics, degradable plastics in the Norwegian system. So we are more or less relying on having the plastics being collected for materials recycling.
Thanks, Helge. There's a question from Tony at SST saying, superb presentation, many thanks. Where do climate change issues fit into your sustainability model?
Yeah, so let me, so this is the industrial ecology model. Climate change drivers and climate change policy and social effects and so on cannot be examined by my industrial ecology model. That, as I said, that would have to be other models. But very many of the environmental and the climate change, let's say, environmental aspects can be. In climate change, it's about understanding what is the emissions of greenhouse gases globally related to what you consume. So in order to be able to try to estimate that, you need to understand the metabolism of those materials and energy carriers that anywhere in the system leads to emission of greenhouse gases. So it means basically you can look at the system, for instance, for the Norwegian domain, the Norwegian economy. You can quantify the plastic flows, plastic product flows and the plastic waste flows and their management. You fill in with the different technologies, and we know the flows in quantity and the technology they are using at different places in this diagram. Then you can estimate what are the emissions of greenhouse gases. And when you know those, then you can estimate potentially what is the climate change driving force. And that leads actually then to what is the likely temperature increase and so on. So the industrial ecology methodology with the life cycle assessment or carbon footprint analysis is actually the methodology that you apply and the approach you apply in order to try to estimate what is the climate change potential in the global warming potential 100-year perspective, for instance. And of course, you use the same kind of information in order to pinpoint where in the system do I have the main problems? Where is the hotspots for those emissions? And then you ask the second question, okay, what should we do in order to try to avoid or minimize that problem? By new ways of organizing or new technologies in order to try to reduce the emissions.
Thanks, Helge. I see there's another question that says, I'm not sure if we've had this one already. Does industrial ecology seek to reconcile environmentalists and economics, or is it a new approach to address environmental problems?
It is partly both, because it is a new approach, because it's a systems-oriented approach. We don't try to solve the environmental problems by understanding what you should do where you see a problem, but what you should do with your system. Because the problem is not necessarily where you see it is. There may be other problems of significant sizes elsewhere. So you need to take a systems approach to that. And that is particularly important related to everything to the climate change, because these are global problems. And in open economies like what we have today in the world, I mean, problems with, I mean, much of the products that we consume are produced in Asia or in Brazil or wherever, right? So we need a systems approach to that. So this is not a very new approach, but it's over the last, since the early 90s. So I would say it's a new approach to how we deal to environmental problems, a systems-oriented approach. And secondly, when you would like to implement the ideas of, or the findings and recommendations from industrial ecology research in the different sectors, of course, they would say, Nice to hear what you are suggesting. However, it doesn't pay off. So we also have to look on the cost side, the cost benefit side. The economics is not necessarily the core activity of industrial ecology researchers. However, there are quite a few of them that also is dealing with, let's say, for instance, environmental economics. They are not so much using life cycle assessment, they are using footprint analysis methods. But that means there is a combination, there is kind of a balance and trade-off between economic impact and environmental impact. So we can't overlook it, definitely not.